BC Calculus. This is topic 59. This is really about what we call constructing a Taylor series or a Maclaurin series. Again, they're interchangeable. The only difference is what it's centered at. So a lot of times I'll just refer them to as Taylor series and not use both terms. So this is something that you will have to be able to do this year for sure. So we're going to use calculus to construct this Taylor series, and all these work the same. So don't make this harder than it is. It's actually very, very simple. Some people like to make this really, really hard, but it's not that hard. Okay, so I'm going to construct a Taylor polynomial. P of x is kind of the notation that we use. The P stands for polynomial. And then a lot of times we'll put a subscript here depending on how many terms we have. Here I have out to the fourth power, which is actually 5 terms, but usually sometimes I'll put a little 4 here to indicate that this is the what we call 4th degree Taylor polynomial, because the highest degree is x to the 4th on there as well. Okay, and because it's just x and not x plus 2 or x minus 2 or something like that, this is centered at 0. Okay. All right, so this is how you construct it. This is kind of the long way of doing it. You'll never have to do it this way. The result at the very end is what you need to worry about. Okay, so P of 0 is equal to 5. So that literally means when I plug in x is 0, I get 5. So this term would be 0, this term would be 0, this term would be 0, this term would be 0. Any term after that would also be 0 because they'd have an x in it. That tells you that A0 is equal to 5, because that would be the only term left because it's the only one without an x. Okay. All right, now I'm going to take the derivative, plug in x is 0, and that's equal to 7. So the derivative of a naught, this is just a constant, so the derivative of constant is 0. The derivative of a1x would just be a1, so p prime x is going to be equal to a1 plus the derivative of this would be 2, a2 will stay there, and then x to the first. And then the derivative of x to the third would be 3. The a to the third would stay there, x squared. And the derivative of this one would be 4, a to the 4, x to the third. Okay, and that's equal, or then p prime at 0 is equal to 7. So this would be 0, this would be 0, this would be 0. So that tells you that a1 is equal to 7. Okay. All right, then I take the second derivative, which is just the derivative of the first derivative. So the derivative of a1 is 0. The derivative of this would be 2a2, plus the derivative of this one would be the 2 will come out front and give you 6a3x. And then the derivative of this one will be 12a4x squared. And then I find p double prime at 0. So this term will be 0, this term will be 0. So that tells you that 2a2 is equal to, in this case, 11. So let me write this over here. 2a2 is equal to 11, which means a2 is equal to, so a2 is equal to 11 over 2. And let's go ahead and put all these results over here. So this will be a1 equals 7. This will be a2 is equal to 11 over 2. a3 is equal to, okay, so now let's take the third derivative at x. So the derivative of 2a2 is 0. Derivative of 6a3x is just 6a3. Derivative of this one will be plus 24a4x. And then when I take the derivative at 0, this term will be 0. So that's just equal to 6a3. And then they told me 6a3 is equal to, in this case, 13. So this would be 13 divided by 6. Okay. So now take a look at these, see if you see a pattern. Well, hopefully it's pretty obvious. This is 5, this is 5, this is 7, 7, 11, 11, 13, 13. I remember these would technically be over 1, right? So without even doing the next one, do you think you can see what the next one is? Give you a second to think about it. And if you can't, that's okay, because again, the results are the thing that's important. Once you go past the third derivative, rather than write 4 primes, they just say 4. So that means the fourth derivative at 0. So the fifth derivative of 0 will be 5, etc., etc. So after the third derivative, you switch to a number. Kind of looks like an exponent, but it's not an exponent to indicate that that's the fourth derivative. So the fourth derivative at x is just equal to the derivative of this. So the derivative of 6a to the third would be 0. Derivative of 24a to the fourth x is just going to be 24a to the fourth. And then we know that 24a to the fourth is equal to 17. So you divide by 24 and you get 17 over 24. Okay. If you're able to see that, good job. And if not, that's okay too. So now do you see the pattern here? Well, from the last topic, hopefully you remember that 2 is the same as 2 factorial, because 2 factorial is 2 times 1, which is 2. 6 is the same as 3 factorial. And this is on the bottom, so let me make sure I write it like that. And then 24 is 4 factorial. Okay. So, and then the 5 is the function value, and then the 7 is the derivative value, or the first derivative value. The 11 is the second derivative value. The 13 is the third derivative value, and the 17th is the fourth derivative value. So that gives us our pattern for setting up any Taylor polynomial. So it kind of looks like this. I want you to memorize out to 6 factorial. So 0 factorial is equal to 1. That's just by definition. 1 factorial is equal to 1. 2 factorial is equal to 2. 3 factorial is equal to 6. 4 factorial is equal to 24. 5 factorial is equal to 120. And 6 factorial is equal to 720. Okay. And again, 6 factorial is like 6 times 5 times 4 times 3 times 2 times 1. But these are good things to have memorized when you're working with series, because these factorials are going to show up a lot. All right, so I'm actually not going to do example 2 at this point. So this is how, using that pattern, this is what we get for constructing a Taylor polynomial. So this is what you do when you construct a Taylor polynomial. You start with the function value, so that could be f at 0, plus, and then it's going to be the first derivative at 0, and then x to the first over 1 factorial. Obviously, I don't have to write the first power here or the 1 factorial here, because 1 factorial is just 1, and dividing by 1 doesn't change anything. But to see the pattern, I'm going to go ahead and write this. So this will be the second derivative, and then x to the second over 2 factorial, plus give you a chance to think about what do you think the next one is if I consider the pattern, or continue on the pattern. It'll be the third derivative, and then x to the third over 3 factorial, and then the next one will be the fourth derivative, x to the fourth over 4 factorial, plus dot 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 plus, and I could continue on forever to the nth factorial, and then x to the n over n factorial. Okay. So this is how you always construct a Taylor polynomial. First thing you need is you need the derivatives, and then it's just follows this pattern. So it starts with the function value first. That function value could be 0, so it's possible that there is no function value term here, because you wouldn't write 0 plus. But after that, it's the first derivative, x to the first over 1 factorial. So it goes 1, 1, 1, and then second derivative, x squared over 2 factorial, so 2, 2, 2, third, 3, 3, 4, 4, 4, 5, 5, 5, etc., etc., etc. And that's how you construct a Taylor polynomial, or a Maclaurin polynomial. Okay? And again, the only difference is this one's centered at 0. If I wanted to center it at 2 instead of x, it would be parentheses x minus 2. And for all the x's here, and that's the only difference. All right, so that's what I just wrote out here, just in printed out form so you can read it a little bit better. So again, it's the function value, the first derivative, x to the first over 1 factorial, which usually we don't write those. Second derivative, x squared over 2 factorial. Third derivative, x to the third over 3 factorial, etc., etc., etc. And then the Taylor series generated at x equals a. So a is going to be something that's not 0. You get the function value at a, and then the first derivative of a, x minus a to the first over 1 factorial, second derivative of a, x minus a squared over 2 factorial, etc., etc., etc. Okay. All right, so your test won't have any multiple choice on it, but they may give you the derivatives and ask you to construct the Taylor polynomial. So it would work the same in free response. The biggest thing or biggest mistake people make is they forget the factorials. So don't forget the factorials. I think I said that earlier in the notes, but I didn't actually read it, but it's in the notes earlier. Don't forget the factorials. They're always part of the construction. So you don't see any factorials here. That's because they've taken that derivative and divided by the factorial to get these coefficients. So the factorials are here, they're just hidden. Okay, so they gave me the function value, the first derivative, the second derivative, the third derivative. Which of the following is the third degree Taylor polynomial? Again, that just means they go out to the x to the third term, about x is 3. So the first thing I would teach you if you were just doing multiple choice is, well, this is centered at 3, this is centered at 3, this one's centered at 3. These ones are not because it's just x. So what are these centered at? And hopefully you know the answer is 0. So these are not correct. So you can eliminate those because these are centered at x equals 0 just by looking at them. Okay. All right, so now I'm going to construct my Taylor polynomial. So I always start with the function value, which is 2. And then it's going to be plus the first derivative, which is -1, x, in this case x minus 3, to the first over 1 factorial, which I don't need to write. Okay, that didn't help me eliminate any answers. Next one will be the second derivative, which is plus 6. So plus 6, x minus 3 squared over 2 factorial. So remember, the factorials are always here, even though they're not in the answer choices here because they simplified it. So they took this derivative and the factorial that's always on the bottom, and they simplified it. So 6 divided by 2 factorial, which is 2, and 6 divided by 2 gives you 3. So that eliminates this answer because that says 6 there. And then it's the third derivative, which is 12, x minus 3 to the third over 3 factorial. Well, 3 factorial is 6, and 12 over 6 gives you 2. So that matches this one, so A is your answer. Okay. So honestly, I think these are super, super simple, and for some reason, a lot of students every year seem to make these harder than it is. Okay. The biggest thing to remember, it's always the derivative, whatever derivative it is, raised to that power over that factorial. So 3, 3, 3, 2, 2, 2, 1, 1, 1, even though we don't usually write the ones, and then start with the function value. Okay? And like I said, in free response, if they give you these, you just need to write it out, and obviously you won't have the answer choices there to compare to, but sometimes the answer choices trip you up anyway. All right. Couple more examples of something you may need to do. So find the fourth order. This could also be fourth degree Taylor polynomial that approximates y equals cosine 2x near x equals 0. So centered at 0, and we're not going to worry about checking convergence on the calculator. So to construct the Taylor polynomial, I need the function value and I need the derivatives, right? So we'll just call it y at 0 is equal to what you get when you plug in 0. It's 2 times 0 is 0, and cosine of 0 is 1. So the function value at 0 is 1. Okay. Then I need the derivative, so I'm just going to take the derivative first with respect to x. So what's the derivative of cosine 2x? Well, derivative of cosine is negative sine 2x times chain rule is 2, so that'll be negative 2 sine 2x. And at 0, sine of 0 is 0, so this would be equal to 0. Okay. Second derivative is just the derivative of the first derivative, so the derivative of this is going to be negative 4 cosine 2x. And at 0, this will be 2 times 0 is 0, cosine of 0 is 1, times negative 4 means that's going to be negative 4. And then the third derivative is just the derivative of the second derivative, so the derivative of this is negative 8. Derivative of cosine is negative sine, so it'll actually become plus 8 sine 2x. Plug in 0, sine of 0 is 0, 0 times anything is 0, so the third derivative will be 0. And then the fourth derivative is going to be 16 cosine 2x. Plug in 0, 2 times 0 is 0, cosine of 0 is 1, times 16 gives you 16. Okay. So if they don't give you the derivatives like they did in that last example that was multiple choice, you actually have to take the derivatives of the function to get the derivatives. And then I just got those values at x is 0. Okay. Now I can write it out. So it's going to be the function value 1, okay, plus the first derivative, which is 0, and then x to the first over 1 factorial. But 0 times anything is 0, so that term will end up going away. And then the derivative, or second derivative, is negative 4, and that'll be x squared over 2 factorial, and we'll come up and clean this up at the end. And then plus 0, x to the third over 3 factorial. And then plus 16, x to the fourth over 4 factorial. Okay. So the Taylor polynomial that approximates cosine 2x, so cosine 2x is going to be approximated by this Taylor polynomial, which would be 1. 4 over 2 factorial is 4 over 2, which is 2, so minus 2x squared. This will be 0. And then 16 over 24 reduces to 2 over 3, so this will be plus 2x to the 4th over 3. So remember, the the factorials are always part of the construction, and so is the derivative. Their factorials aren't always in the final answer because you can simplify that derivative divided by the factorial to simplify it down. So if I were to graph this in my calculator and graph cosine 2x on the calculator, you'll see that they are basically right on top of each other because they're pretty good approximations. Okay? And remember, the notation for this would be this is the 4th degree Taylor polynomial. So it'd be, the notation might look like that. Okay. This would be an equal sign because the 4th degree Taylor polynomial is equal to this, and that's the approximation of cosine 2x. All right, let's do another one. So this one's easy because the derivative of e to the x is just e to the x, right? So, and then the function value at x is 2 is just going to be e squared. And we'll just do the 3rd degree Taylor polynomial since I didn't specify which one it was. Okay? So it's going to be the function value, which is e squared. And then plus the first derivative is just going to be e to the x is e to the x. Plug in 2, you get e squared. Because it's centered at x is 2, it's not just x, it's x minus 2 raised to the 1st power over 1 factorial. And then the second derivative at 2 would also be e squared, and then this will be x minus 2 squared over 2 factorial. And then e squared will be the 3rd derivative as well, x minus 2 to the 3rd over 3 factorial. Okay. And it's okay, it's perfectly okay to leave it like that. In this case, it doesn't simplify, so because e squared divided by 3 factorial is not going to be a whole number, an integer, so it wouldn't really make sense to simplify it. Up here I did simplify it just so you can see again that you can simplify these things, but it's totally okay to leave it like that. Okay, and actually this should say x minus 2, not just x. All right, another example, find the 3rd order or 3rd degree Taylor polynomial. And we're just going to do this one at x is 0 since we probably won't have room to do both of these. So let's just cross that one out. Okay. So I need the derivatives so that I construct the Taylor polynomial. So the first derivative of this is going to be 6x squared minus 6x plus 4. And then the second derivative will be 12x minus 6. And the third derivative is just 12. And I need the 3rd derivative because it's the 3rd degree Taylor polynomial. So that tells me how many derivatives I need to get. Okay. All right, and now I'm just going to construct that. So if I plug in 0, that's 0, that's 0, that's 0. So the function value is negative 5. So the 3rd degree Taylor polynomial about x is going to be negative 5. And then the first derivative, when I plug in 0, that'll be 0, that'll be 0. This will be 4. So it's 4 x to the 1st over 1 factorial, which again, you don't have to write those. When I plug in x is 0 here, the second derivative will be negative 6, and that'll just be x squared over 2 factorial. And then the 3rd derivative is just 12, x to the 3rd over 3 factorial. And now I am going to simplify this one. So the 3rd degree Taylor polynomial is negative 5. This will be plus 4x, and this time I'm not going to write the 1 exponent of the 1 factorial. 2 factorial is 2, and 6 over 2 gives you 3, so that would be negative 3x squared. And this is 3 factorial, which is 6, and 12 over 6 gives you 2x to the 3rd. Okay. So do you notice anything about this Taylor polynomial approximation here? Well, guess what? It's approximating the Taylor polynomial, or the polynomial here. So since this is a polynomial, it makes sense that the Taylor polynomial approximation of a polynomial would give you the same thing, because we're approximating a polynomial, which is this, with a polynomial, which is this, and this are the same thing. The order is just reversed. Okay. So that just kind of proves that it works out. All right, so a couple multiple choice questions, obviously, but these are really good as far as do you understand the concept. So what's the coefficient of x squared for this Taylor series 1 over x plus 1 squared about x equals 0? Well, guess what? To construct the second degree Taylor polynomial, what do I need? Well, I need the second derivative and divided by 2 factorial, because that'll be the coefficient once I simplify this down. Okay, so this is the function, so I need the second derivative. A good way of rewriting this one is 1 plus x to the negative 2 power. So that's my function. And now I'm going to take the derivative in this form with just the chain rule and power rule. So the derivative is negative 2, the inside stays the same, subtract 1 to get negative 3 times the derivative of the inside, but that's just 1. And then I don't need to simplify that because I really only care about the second derivative. So the second derivative is going to be positive 6, 1 plus x to the negative 4 times the derivative of the inside, which again is just 1. So that's equal to 6 over 1 plus x raised to the 4th power. Okay. So, and this is just at x is 0, so I plug in 0 on the bottom, 1 plus 0 is 1, 1 to the 4th is 1, so 6 over 1 just gives you the second derivative is equal to 6. Okay. So don't pick this answer because remember, it's the second derivative divided by the factorial, and 2 factorial is 2, and 6 over 2 gives you 3, so that's the coefficient for that series for the x squared term. All right, next one. Polynomial is 3x squared minus 5x to the 3rd plus 7x to the 4th plus 3x to the 5th. That's the 5th degree Taylor polynomial because, again, it goes up to the 5th degree or the 5th, 5th degree. Remember, it doesn't mean there's 5 terms. A lot of students confuse that as well. About x is 0. What is the value of the third derivative? Okay, well, the long way of doing this is take the derivative of this 3 times. And that's not hard, but it's longer to do. So the quick way of doing this is, well, where do I find the third derivative? Well, I find the third derivative in front of the x to the 3rd term, right? So the third derivative divided by 3 factorial is always what's in front of the x to the 3rd term, right? So in this case, that's negative 5. So as the coefficient is negative 5. So I know the third derivative divided by 3 factorial, which is 6, is equal to negative 5. So to solve for the third derivative, I just multiply each side by 6 to get rid of that, and the third derivative is equal to negative 30. Boom, that's my answer. Okay, so knowing where to find these things, knowing about the construction, that's what's super, super important. Okay, so for instance, for the 5th derivative, if I was looking for the 5th derivative, that's going to be that over 5 factorial, and that's equal to, in this case, 3. So the 5th derivative would be 3 times 5 factorial, which is 120. So the 5th derivative would be 360. Okay. All right, last example. This one, there's actually an easier way of doing this one if I had you memorize it, but this is actually a good example of taking the derivatives as well. So the function is sine x, which means the first derivative is cosine x, which means the second derivative is negative sine x, and the third derivative is negative cosine x. Okay. They say go to the 5th degree Taylor polynomial, so technically I need the 5th derivative, so I need to keep going. So the derivative negative cosine x takes me back to sine x, and the 5th derivative is the derivative of sine x, which is cosine x. All right, so now I'm going to construct my Taylor polynomial. So the function value at 0 is equal to 0. I probably shouldn't do this, but f at 0 is equal to 0 is a shorthand. Cosine of 0 is 1. Sine of 0 is 0. Cosine of 0 is 1, but there's a negative in front, so that's negative 1. Sine of 0 is 0, and this one is 1. Okay. So start with the function value is 0. I wouldn't have to write that, but I will. And then the first derivative, x to the 1st, over 1 factorial, and then plus the second derivative, which is 0, x squared over 2 factorial, third derivative, negative 1, x to the 3rd over 3 factorial, fourth derivative is 0, x to the 4th over 4 factorial, and then plus 5th derivative is 1, x to the 5th over 5 factorial. So this term 0, that goes away, that term 0, that goes away, that term 0 goes away. And we're trying to find the value of sine 1, which literally just means replace x with 1. So all of this just becomes 1. This will be minus 1 over 3 factorial, which is 1 over 6. So this will be, plug in x as 1, you get 1 over 6, which obviously tells me that's the answer. I'll go and do the last term, plug in 1 here. 1 to the 5th is 1, times 1 is 1, and 5 factorial is 120. So That's your answer. So again, if you had memorized sin x, which is usually something they have you do, all you would do is write the series for sin x and plug in 1. But in this case, we just constructed it because that's what they're going to be asking you to do this year. All right, I think that's it for this one. So again, this is all about constructing a Taylor polynomial or constructing Maclaurin polynomial. The only difference is what they're centered at. So it's always the function value, and then first derivative of x to the first over 1 factorial, second derivative of x squared over 2 factorial, third derivative of x to the third over 3 factorial. That's always, always, always how you construct these Taylor polynomials. Okay, don't make it harder than it is. It's actually pretty simple.